Hey everybody, this is Mr. Conklin. Hopefully this will work. I tried to record this at home, but my home technological stuff failed me, unfortunately. So I'm going to try this. I'm actually recording this on my iPhone here at school. This is the CLT prep session, the very first one. We're going to be going through test 1, edition 1 from the 2018-2019 test. That should be the one that Mrs. Denbraber photocopied for everybody. I'm going to try my best to squeeze it in this side of the paper. I hope that'll work. It's not all the paper showing up in the. I have this little tripod stand thingy that doesn't extend very far, but we'll make it work. Anyway, there are two problems I'd like to go through today. Problem number 81 and problem number 82, which are the first two problems in the CLT math section. Number 81, let me just put this underneath. Hopefully you should be able to read a bit of that. I'll read it off real fast. It said, Josephine's ice cream shop always makes sure its sundaes maintain a ratio of 4:1 for ice cream to toppings. So basically 4 pints ice cream, 1 part topping. A group of friends orders sundaes and receives 5 cups of ice cream total. So how many cups of toppings total did they receive? Now, part of the issue here is a ratio of 4:1. You might think, well, 4 scoops of ice cream and 1 scoop of toppings. That would work, but it doesn't absolutely have to be. Let me move this over here for a second. If you have a ratio of 4:1 for ice cream, I can squeeze this in here, to toppings, I'm hitting the stand here. Sorry. I'm going to scoot this down here so everybody can see a little better. You could have 4 parts ice cream, 1 part topping, but you could also have 8 parts ice cream to 2 parts topping. Do you see that would be the same proportion? It reduces to 4:1. Or you could have, like, I don't know, 40:10. You can multiply it by anything, basically. So basically, since if we don't know exactly how much we're using, it could be 4:1 or 8:2 or 400:100 if you have a big party or something. All we know is that we're multiplying both of these by some mystery number x, some mystery number like it might be twice as big times 2, or it might be 10 times as big. We just don't know. So we're going to do this: 4x to 1x. So x is just whatever multiplier you want. Does that make sense? So this could set us up for any amount you want. If x is equal to 7, it'll still be the same proportion. It'll be like 4 times 7 is 28 to 7. So 28 scoops of ice cream to 7 scoops of topping. It'll be the same proportion, 4:1. But this will allow us to just put whatever multiplier we want. Now here's the sneaky part. 4x is the amount of ice cream. And 1x is the amount of topping. The nice thing about having an x in there is that if they were to say, hypothetically, which they did, they had 5, whoops, it's not on screen, 5 cups of ice cream total. Look here, this is how much ice cream we have. So if we have 5 cups of ice cream, that 4x is equal to 5. Does that make sense? And now we can actually divide that out and find out what our mystery multiplier is. That'll come in handy. X equal, it's not a whole number, unfortunately. It's 5/4, or for you who are addicted to decimals, 1.25, or 1 1/4, if you like mixed numbers. Now that's interesting. So how much ice cream do we have? Just to prove it, ice cream, I can spell. And the amount of ice cream we have is, what am I doing? Is 4 times x, which is 4 times 5/4. And if you notice, times 4 divided by 4 cancel, so we have 5 cups, which is what we figured in the first place. But how much topping? The amount of topping is 1x, which is actually pretty easy to do. 1 times 5/4 is just 5/4 cups. Or if you want to put that as a mixed number, 1 1/4 cups of topping. Now, let's take a look at the choices that they gave us. So it said how many cups of toppings total, sorry, so you can see the whole thing. How many cups of toppings total did they receive? And lo and behold, we have a choice B of 1 1/4. So it should be choice B. Does that make sense? All right, let's scoot over to 82. It says a family is packing for a move. Sorry if it's curvy here, I'll read it off. They put all of their clothing into boxes that are 12 inches wide, 24 inches long, and 20 inches high. So 12 by 24 by 20. If their shipping container, I don't know if anybody's ever done this, this could be a U-Haul truck, it could be something, I don't know if you ever heard of something called a pod, which is basically a big box, a big huge box that a semi-trailer comes to pick up, and where you store all your stuff. If the shipping container is 3 feet wide, 6 feet long, and 5 feet high, how many boxes can they fit inside it? One teeny little thing to note, in real life, if you have a box that's 12 by 24 by 20, you can rotate it and you can flip it over and whatever to however it can fit. They're assuming that you keep the box steady, that you don't flip it upside down, which kind of makes sense. If they're breakables, it would be bad. They don't want you to rotate it either. So they don't want the front to be the side to be the back, or something like that. In real life, you probably would, because you could stick things in. But just to make this problem easy, they're keeping the boxes all in the same orientation. So if the 12 inches wide is in front, the 3 feet is in front. So these match up. Does that make sense? So the best way to do this is to draw. This is problem number 82, by the way. A box will look like this, and I'm going to try my 3D skills here. So it's 12 by 24 by 20. And I probably didn't make this look very accurate, but whatever. So 12 inches by 24 inches by 20 inches. I should have made that look taller. But, yeah. So that's a typical box. Now, the container itself is quite a bit bigger. The shipping container is 3 by 6 by 5. So 3 by 6, and I'm going to mess this up again, but whatever. 3 by 6 by 5. You don't have to make it look like a work of art. I didn't. 3 feet by 6 feet by 5 feet. And again, they're going to keep these exactly the same. So if this is the front of the box, it's going to be facing the front of the storage container. Okay. Now, how many of these can we fit in here? Note, this is 12 inches and this is 3 feet. In order to match them up, we have to have the same units, the same type of measurements. So I think the easiest way to do this, you could change all of these into feet, but this is going to be a decimal or some type of thing. I think it would be a little easier to change these into inches. So 3 feet, if you remember, 12 inches is 1 foot. So just multiply these by 12, so 12 times 3 is 36 inches. This will be 72 inches, I think. And then 5 times 12 will be 60 inches. Okay, so I want to know how many of these boxes can fit into here. Well, 12 inches out of 36, that's 3 of them. So you can have 3 boxes wide. You see what little dashes I did there? So it'd be 1, 2, 3. And then how deep is it? How many times is 24 going to 72? That goes in 3 times. So 1, 2, 3. You notice the slick little slanty perspective thing I did there. So it goes across 3 and deep 3, and then how tall? 20 goes into 60. That's 3 times. So, and again, you don't have to draw this fancy schmancy 3D thing. But do you see here? I'm just going to finish this off. The boxes are, like, here's our original box. Like the front of this box is the front of that box. Okay, so it's going to be 3 boxes wide, 3 boxes deep, 3 boxes tall. So 3 times 3 times 3. The total number of boxes, and you can count them up if you want, is 27. And so if you look at the choices, 3, 9, 27, or can't fit any boxes in, that would be pathetic packing job. But it's 27, so in this case, it's choice C. Okay, that's all I have for you now. So hope you enjoy. I'll try and post this on YouTube in a way that everybody can access. Take care. God bless. Talk to you later.